Welcome back to Yamashita's and Martin Despang's show Urban Transcendence. So the next three shows will be about the making of how we transition and transcend into a more in balance with the elements environment here on our islands of Hawaii, specifically here on our island in Oahu, city of Honolulu. So we had one show about building materials that was at the very beginning. It was with our friends from EcoShade, Brian and Eric. It's a building material I ran into at the very beginning, and I got excited about it. We could probably call it the tropics, referring to our previous guest Thomas Lim, who says something that comes here and complements the environment culturally and climatically is a species of the tropics. So today's show is called, and that's going to be more challenging, although more educational, more enriching, it's called Cool Concrete. And our guest today is Mr. Concrete on this island here, Les Kempers. And Les is going to introduce us to his material in general, and then also we go to some specifics in pointing out potential ways how to even innovate even more. So thank you very much for being on this show, Les.
Sure.
It's a pleasure.
Thanks for having me.
And we've known each other for a while. I've just been back from Iowa, and where you are an alum from Iowa State University. So we have sort of two Midwestern guys here. And so tell us a little bit about, where you come from and ever since, when you were in touch with this material of concrete.
Well, I started with, right out of graduate school, I got my master's in structural engineering, and my thesis was on dapped ends of double T's, which this is a little prototype of a double T here. And following that, the company I did the testing with hired me. So I worked as an engineer, as an engineering manager, and then worked in the production facility, managing that. And later was a project coordinator, went into marketing and sales. So I've kind of gone through a lot of different steps in the same industry, although it's been like having a different job in each category. Then in and that was all in Colorado, in the Denver area. Then came out here in '99, where we had started a plant in Hawaii, and have been here since '99, trying to create a market with precast. There has been a lot of precast done here in the past, and our forte, I guess, would be doing all precast structures, where it's everything from the ground up, from the foundation up, is precast elements. So that's what we've been striving to do. The company name is GPRM Prestress, which stands for Grace Pacific Rocky Mountain Prestress. It's a mouthful, but in 2006, prior to that, we were Rocky Mountain Prestress, and there was Grace Pacific Precast. And in 2006, we saw the advantage to merge and take the synergy of each of our strengths and put them together to become a larger company with more expertise.
Thank you. So with our kind of critical format, the audience is probably really, really anxious and waiting for why in the world can concrete be cool and even worth talking about, because concrete is something that's very known to people, and not necessarily is everyone excited about as we are. So hopefully after this show they will all be, and I'm pretty sure they will. So stepping back a little bit from a sort of my moderating point of view as an academic and practicing architect, having, I've only been here 2.5 years, so when I came, it took me a while to understand that actually different to the past, where a few people have lived here, and they basically just took as a building material what they could find, which was sticks and wood and thatched, with the explosion of population that created a lot larger demand. And so the question is, how do you provide, sort of feed that demand? And so, so concrete was a material that sort of came in handy, was also obvious because where we both sort of came from, the Midwest and America had really embraced concrete as the material of growth. So basically it's getting this material here, which people might say, well, that's invasive, that's not tropics. But we're going to make the point that actually concrete is if not the main or if not the only sort of local material. And why is that? And we do a little demonstration that I'm going to help, so you're going to explain, and I'm going to be your assistant.
Okay. So yes, I would say that Hawaii is a concrete state. Everything that's steel has to be shipped in. We do ship in the cement, but other than that, most of the materials are local. So Martin is showing you some of the gray cement that's used. It's a little bit clumped up there. It's not powdery, but, and one thing to note, as most of you should know, if you don't, that is cement. And these concrete pieces are not called cement, they're called concrete. So cement is the powder as flour would be for bread. It's an ingredient, and concrete is the final product. So the basic materials are the cement that he poured out, and then we have a little container of sand, and that's our local basalt sand, and then there's some 3/8 inch aggregate. We have different sizes of aggregate that's also basalt. So in Hawaii, I kind of joke with people and say, you have three choices for aggregate in Hawaii. You have basalt, either basalt or basalt. And that's really all we have. We do have coral, but coral is a difficult material to manage in terms of water because it's so porous that it's hard to control your water content. You can either have too dry a mix or too wet a mix. So basalt is really the material that is used exclusively for concrete in Hawaii.
So you already mentioned the fourth material, which is this one here. Which
yes.
So I'm going to put it down again. Maybe
yeah, water's the fourth material, and then we also put some additives in, liquid additives, that will help with the viscosity of the concrete, to help with pouring it and the workability of it. And then there are other additives you can add in for corrosion protection and for density, getting a more dense concrete. And then when we use, and that's not what we're talking about now, is more the gray concrete that you see everywhere. The other side of that is architectural concrete. So with architectural concrete, you would be using white cement in lieu of the gray cement. And then you would be using different color aggregates if they're available. Now in Hawaii we don't have that. So in our case we use pigment with the white cement to get different colored panels.
So as the picture in the background basically shows, is a project we both worked on and you collaborated. So that was a proposal to basically use potentially red pigments. However, there was another idea that I had that you taught me about the complexity of things and about the relativity of sustainability, because I came from Arizona and was excited to say I have a research collaborator, David Stone, who uses basically a metal, an iron powder. It's a byproduct from the steel industry. So we could compensate the cement, because the cement is the problematic one in two ways, because it needs to be brought in. First of all, creates a footprint, and secondly, it's the one that uses the most energy and puts out the most CO2 when being produced. So my idea was to make up for that and improve, and you said theoretically great on the mainland, close to be perfect, but we don't have steel production here on the island. So this needs to be shipped in, and it creates another logistics, and so it basically is sort of problematic under the circumstances of us being isolated, whereas you have the other system, so to speak, set up. And you were telling me about another material that is about to become a substitute for cement, right?
Yes, the fly ash is beginning to be used now in Hawaii. It does act as a substitute for the cement. The challenge still is, though, that with the logistics, it's still more expensive to create a concrete mix with cement and fly ash substitute as opposed to all cement. But I think with time that will probably change, and it does make a more green material. Yeah.
So we covered the concrete itself pretty much due to the basically structural way concrete is working. It's great with, and you being the structural engineer by education, and I'm the one who's teaching that, by the way, our School of Architecture. So us together, we can say it's great with compressive loads.
Mm-hmm.
When there come tensile loads, not so much. So what does that mean? And there's some sort of consequences behind.
So yes, what I tell people is that concrete is happy in compression and it's not happy in tension.
Mm-hmm.
The compressive stresses can go very high, up into 5 to 10,000 psi, pounds per square inch,
Mm-hmm.
and tensile stresses go much lower than that. They're around the below 500 psi, and you're going to have cracking. So some of the elements we produce compensate for that by using pre-stressing. So conventional reinforced concrete will have concrete and then rebar, as everybody knows.
Mm-hmm.
And there's a substitute for the rebar, before I get into pre-stress, that we've been using for a few years. We've done a couple high-rises with this material, and I happen to have brought a piece along. This is called carbon cast. It's a carbon fiber in strands that are going just the way you see them, and then there's a resin coating on that. So this is basically used in place of a steel mesh in a concrete panel. So the result of using this allows us to go much thinner with our panel, because we're always concerned about concrete cover and corrosion of the steel in a panel. By using this, there is no concern of corrosion, because this will never corrode.
Mm-hmm.
So this has been an element that we've used in buildings that require a lighter panel, such as
Mm-hmm.
a 40-story building, because of our seismic considerations. So you
Mm-hmm.
want the weight on the building to be
Mm-hmm.
as small as possible, so you don't have to design for those huge seismic loads. So this has been a good new product for the industry.
And that's an innovation in many ways, as you pointed out. Probably people who are have more reservations towards concrete. That comes from basically they see old buildings. Basically, they think concrete lasts forever. Frank Lloyd Wright, as one of the most important architects, American architects, called it liquid stone.
Mm-hmm.
So he, makes us aware that there's a fantastic poetic quality to this material. But the pragmatic side is that in the old days, where technology wasn't there, we have this problem of spalling, and basically, the rebar is corroding and expanding and making the concrete crack, and we see all these renovations going on. So this material is going to help with that, and it's not going to make this happen again in the future.
Mm-hmm.
And then, as you said, as you told me, by now, as with every new technology and building material, at the very beginning, the substitute was very expensive, but now the more the industry uses it, the price goes down.
Mm-hmm.
So it's almost at the same price level, but you save material because you can make the concrete a lot thinner.
Not only making the concrete thinner, but you're making the foundation system lighter, because it's not having to resist the loads of a heavier building,
Mm-hmm.
and the frame itself can be lighter as well.
Mm-hmm. Mm-hmm.
So there's advantages on that trickle down all the way
Mm-hmm.
to the
Mm-hmm.
foundation.
Mm-hmm. So, and then sort of the introduction to, when you talk about the pre-stress in a minute here, and again, you even have that put in the nice little bonsai twin tee here. We can even see the pre-stress
Mm-hmm.
members here. I don't know, the camera can probably not get that close, but you do a great job. Thank you. But before that, just to the audience, if people drive around and there's a lot of construction going on, not everything what they see is what we're talking about, because concrete, you can actually, build with concrete in two ways. You can do it a more ancient way, I call it, which means you do it on site. You got to make the cast outside, you're exposed to the elements. You got to train people really well outside to do it under circumstances. They're always different.
Mm-hmm.
But you're talking about a different system, and maybe you clarified a little bit better what prefabrication with concrete actually means and where the benefits are.
Sure. So we have a plant in Campbell Industrial Park near Kapolei, and we have 20 acres where we have some stationary steel forms that we pour elements that are repetitive, like the double T, like hollow core that we'll see in a minute.
Mm-hmm.
and steel and columns and wall panels and foundation piles and bridge girders. So those are some standard shapes that we have. In addition to that, we can build forms for any unique shape that you have, and I try to equate precast concrete or concrete in general to Jello. Whatever you can make the mold shape, you can pour in the concrete and it'll take that shape. So it's very, as you mentioned earlier, a liquid material is, you can do a lot with it. So our plant in Campbell Industrial Park, we pour our panels there, and we're a PCI certified plant. What that means, we're a self-policing industry. So we have someone from the mainland come in twice a year unannounced, and they will critique our plant for 2 days, and unless you score an 85 or better, you're on probation. So we try to keep the quality of precast high so that it's a benefit to the owner to have that. So we will make our products in the plant piece by piece, and then they'll be loaded on the trucks, trucked to the job site, and then a crane will erect them. Somewhat like a big set of Legos, as we talked before. It's just much bigger equipment to handle them and erect.
Great. So we're going to take a little break, and then we're going to be back to talk more about that exciting topic of pre-stress concrete with Les Kempers.
Okay, thanks.
This is Alice Lee Hagen, host of ThinkTech Hawaii Business Education Spotlight. My show here at ThinkTech Hawaii is every Thursday from 3 to 4 in the afternoon. I bring in interesting guests from Hawaii, the mainland, and hopefully international guests in the future. Do join us on Thursday from 3 to 4 p.m. ThinkTech Hawaii Business Education Spotlight. Aloha.
Hi, my name is Seymour Kazimirski. I have a show called Seymour's World on ThinkTech Hawaii. Our show is about opening minds and facilitating conversations. To tell you the truth, I have no idea what we're going to be talking about. I have no idea who our guests are going to be, but I guarantee you we're going to have lots and lots of fun. Aloha from Seymour's World.
All right, we're back to our show today, Cool Concrete with Les Kempers. So you basically described just before the break that you basically can score and point with having everything being really set up on in your plants, so the quality control, also safety, job safety, everything is certified and controlled, and so that's your environment. And then on the job site, you cut down the construction time to a minute because everything is already ready. We can think of it like Lego. Right. You just put together in a couple days, as opposed to weeks or months out there when you have to put the cast. And the higher you go in a conventional building, the more tricky it gets to. You have slip forms, you can do that. You can kind of optimize that cast in place as well, but it remains pretty painful, I would say.
Yeah, I would say a big advantage of precast is that while the general contractor is on the job site pouring his foundations or after his demo work, his grading, whatever, that in that same time period, we're building their building in our plant. So usually by the time the foundation is ready for the first piece of precast, we have between, say, 60% and 100% of their building already cast. So then it's just a matter of shipping the panels and erecting, and that process is much faster than forming and pouring on the job site. And there's less congestion, so it's really a safer, cleaner job site as well.
Yeah. And for that, you actually have developed two of your favorite sort of systems that you provide, especially for horizontal members, and one is actually on the floor here. So if we could please go down there and check this out, and you can explain a little bit what we're looking at.
Yeah, we have two basic horizontal members. One is the hollow core piece that you're going to see on the floor there, and that's basically an extruded product. That's typically, this is just a little section of it with 2 holes in it. But our product is 4 foot wide in the form, and it's either 6 or 8 or 10 inches tall or deep. And then it has 7 holes in it. So in between those, you can see the little dots on either side of the holes, and those are pre-stressed strands. So the pre-stressed strands are what's given it the tensile capacity of the member. So that's a product, and that's extruded kind of like the old little Play-Doh things that you had that you would pull a lever and it would extrude the concrete out. And the machine will also densify the concrete with high vibration. So that's one horizontal product, and that's the advantages of the hollow core are that it's a shallow product. So if you have a tight floor-to-floor system, the hollow core is a good product for that, and you can usually leave the ceiling of your space untouched, just paint it. The other product, which is the little prototype here, is the double T. The double T's probably one of the most efficient members there is in precast. And as Martin said, you can see the little pre-stressed strands on the end. So when you look at a double T and it's spanning, let's say from my finger to my other finger, you see some camber in the piece. When you load the piece, it's going to want to crack in the leg. So that's where the tension's going to occur. So by putting these pre-stressed strands in here, and typically they're spread out at the end, and then they're bunched together in the middle and then spread out again. So you're getting this high tension right in the middle here, and that's compensating for the tension of the load in the member. The other advantage of this system is that the double T leg in real life is about 4 inches thick at the bottom and 6 inches thick at the top, so it can strip out of the form. And so it's not only serving to carry that tension force into the member, but it's also a fire rating for the member. And then the deck is typically 2 inches thick. So that's basically your form. Once you set this and pour a 3-inch topping on it, say in a parking structure, now you have your 5-inch deck thickness, and there's no forming to do on the job site. So a good way to think about this is a typical parking structure member will weigh about 50 pounds a square foot. And that's equivalent to a 4-inch thick flat slab piece of concrete. So if you can envision a double T can span 60 feet and support cars on it, a 4-inch flat slab spanning 60 feet, there would be no way. So it's a very, very efficient use of materials, which is why it makes it so economical to use.
It's a great explanation through demonstration. Thank you very much. So the show looking for innovations, how we can do even better. So I just had to suppress my smile because when I was looking at the camera, what the camera was showing reminded me of what I told you before we went into the show, where I basically said the show is only going to capture from here up, and all of a sudden I saw my feet down there, which were demonstrating the island tropical style. And what actually the audience is seeing in the back is just that. This is the project that we've been developing with Thomas Lim, who was our guest a couple of weeks ago, and we call this the tropical textile. And it basically tackles one other thing. We're not afraid to also, sometimes agree to disagree here. So maybe we should talk about the potential touchy subject of thermal mass that we agreed we can talk about and exchange opinions. So maybe you share your thought about it, and then I follow up, and so it goes.
Certainly on the mainland where you have the 4 seasons, thermal mass of precast and concrete in general is an advantage because you've got the temperature lag of heating up during the day, but the concrete's already cool from the night before, so you're getting that advantage of not having the building heat up so fast during the daylight hours. And then at night, when everything's opened up and people are gone home in an office building perhaps, then the building's cooling down, so you have that just automatic thermal lag, which is beneficial and can actually reduce your mechanical requirements on a building. My opinion is that also in Hawaii, even though the temperatures are quite constant, it's probably not as big of an advantage, but if you go in any concrete warehouse and then go into a steel warehouse, which I kind of like the tin exteriors, they heat up almost immediately, whereas a warehouse that's concrete, you're going to have that same thermal lag, which will keep your warehouse or storage or any kind of building cooler during the day.
And that's fair argument. And although I always teach my students, thermal mass in a temperate climate no thermal mass in a tropical climate, but then it's also important to point out the shades of gray. And that gets us to another potential innovation that actually in the cutting edge architectural profession has been done for a couple of years, which is the thermally activation of concrete. Maybe you want to talk about that as well, or
In what,
I can.
in which way?
The thermal activation, where you basically say where maybe the lack between night and day, like in the tropics, as you pointed out, isn't enough. You could sort of artificially activate that through using other energies, and you know, you do it. You can do it with the Bonn Deutsche Post headquarters by architect Helmut Jahn did that many years ago, where they use the water of the River Rhine that goes by, and they basically funnel that river water, actually not actually, but they have basically tubes going into the river, and it's like your radiator in your car if you have a water radiant driven car, a cooled car. Basically they use that liquid to basically suck out the heat, if we're in a summer condition, out of the concrete slab, and constantly flush it with cooler liquid. And that's something that the architectural profession here is excited about. They call this seawater air conditioning. It's basically using the benefit or just the property of thermal mass and using that. I'm, as a critical thinker, always say, you know, if we're worried about the corals, they're very sensitive about 1 or 2 degrees higher, then they're not going to do it anymore. So I'm thinking if we heat up the ocean, but that's probably not, maybe if we're here, that's for another show, but I think we got to think more comprehensively and not jump on sort of pre-conclusions too early, but that's at least the potential. So what the people saw under the table is me being in slippers, is what that tropical textile, that's the working title, thanks to David Rockwood, by the way, who we're going to meet after the show. He gave that project the working title, where we actually try to minimize the exposure of the exterior wall, and we make it a structural, an exoskeleton that basically exposes the least surface to the sun, and then has depth and is open in the most maximum way. So basically the best, because abundant air conditioning here, the trade winds, is basically going to help to cool the building. And I have to thank you here as well. I have been sort of, for many years before I came with Glenn Miyasato, that I'm always also thinking, because I'm co-teaching structures in our school with him. You've been very active in educating our students, have invited them to your plant. This is always the highlight of your course. It says a lot about me, but more about you as well. So that's always great. And that's how actually also we use that sort of also as the acquisition for this show, because Alejandri and I were there with the students last time. We thought this needs to get on the show, basically. So we basically want to do that. And so the students then get excited about it. I once had a student in Nebraska. She went to your colleagues in Nebraska and was showing up there and was looking at chimney rocks, basically the hollow square blocks that you vertically stack. And she looked at them and said, let's flip them on the side and make a wall out of it. And the guys were like totally saw this young, you know, woman there looking at their material so differently. And they felt very honored and said, this is really great that you look at our material so differently, meaning poetically. So we have the same happens here, that you actually, many students were very, very inspired and encouraged by your technologies. We have Alessandra actually looking at your hollow core and saying, well, it sure saves weight, so it saves material. But the hollow cores, if she goes for a more bioclimatic way of cooling the building and basically not enclosing it but leaving it open, she thinks about leaving the cores open and orienting them towards the trade winds. And then you had a great idea, reminded you of your cool roof of your own house. And you had the idea of little fans maybe helping. So I think this is a great collaboration between that you teach the students what they need to know to get a job and they feel comfortable with the material, but then they also come back and teach us with great ideas. So because everything needs to have evolution and needs to progress, and so that's a great win-win.
Another good example of what she's working on with the hollow core tubes. Back in the mid 80s or early 80s, Skidmore and Merrill, SOM from Denver, Colorado, designed a building in Colorado that that had a basically a precast office building, but it had a skin of glass 5 feet out. And they used the cavities of the double T, and then they furred out the bottom, so it became a chase. And they were running that solar heated air through the chase and down through the basement, which was full of big rocks, and heated up the rocks during the day. And then at night they were, well, and then they would store that heat and then cycle it on the cold days and not have to use so much of their mechanical system for heating.
That's great.
And that was back, you know, quite a while ago. They're quite innovative.
All right. We go into another break, and then we're going to be back with Les Kempers and his cool concrete.
Okay, thanks.
Hi, I'm Jay Fidel. I'm host of Hawaii, the State of Clean Energy, which is our flagship show, which plays 4 to 5 p.m. every Wednesday. And the supporters of that show are Hawaii Energy Policy Forum and Hawaii Energy. And luckily enough, we have representatives of both of them right here today to tell you more about what they think about the show. Sharon Moriwaki at my left is co-chair of Hawaii Energy Policy Forum, and she goes first. Sharon?
Thank you. Thank you, Jay. I'm so glad that we have this Hawaii, the State of Clean Energy. This was 2 years ago when we started this, and we have continued it because it's so important, and there's so many developments happening across the state. And we hope you'll tune in every Wednesday, 4 to 5. It's wonderful.
And Ray is Hawaii Energy. Ray, what is your thought about the same subject?
Well, I agree completely with Sharon that we are talking about every Wednesday, 4 to 5. We talk about some of the most important subjects that are affecting the islands now and into the future. Energy, clean energy, we need it. We often run into new ideas that we had not thought about before. We did just today, and I think we're going to have more of that in the future. So come on down and watch us 4 to 5 on Wednesdays, and we'll see what happens.
We'll see you then. Aloha.
Aloha.
All right, welcome back to today's Urban Transcendence about cool concrete with Les Kempers. So I think we covered quite a bit sort of the performative aspect of concrete, as well as what it's made of and what it does, how we can optimize it structurally and also sort of bioclimatically. I think the biggest issue, probably besides the cost for the people, is the aesthetic. And there has been, we're actually here, if the camera could look up, we're in an all-concrete building here. Pioneers Plaza is one, and actually one of my favorite ones outside across the Pioneers Mall is actually Bank of Hawaii by Victor Gruen, who was the inventor of the shopping mall, but then he went away to Austria, where he came from, because he said, if you would have known what capitalism does to his great idea, but that's for another show. Again, that's a great project actually that I love because it tries to be local and using the local aggregates that you've shown us. So you also have a couple of samples here. So let's talk about the formal aspect of concrete and the surface and the options people have.
So what I've brought here for samples today, if you look at this row of white samples, these are not local aggregates, but it's for a local job that we're doing right now. So when you look at the panel as it would be poured right out of the form, this is what it would look like. So it's just an off the form white finish. And then as you do some processing, this particular sample has an acid etch finish. So it's been processed with some hot water at high pressure and just a little bit of muriatic acid to help cut away the matrix. So as you cut away the cement paste, you start showing some of the sand. And I don't know if you can see the sparkle in this or not, if you get it at the right angle, but there is some mica in there which gives a sparkle. Another finish is a sandblast finish. The sandblast will not be quite as fine as the acid etch finish. The acid etch will leave you crisp lines and very sharp features. The sandblast, I always equate it to more of an adobe look, where it's more of a dulled finish, because you're actually dulling the finish with your sandblasting operation. But you do get about the same depth of etch, and it's maybe hard to see in this light, but you start to see some of the sand particles. If you continued to sandblast, you would get to this piece here, which you can see a lot of the aggregate. There you can see it there.
Yeah.
And that's a much deeper sandblast. You're starting to show the actual pieces of aggregate. And then another process that we do is a polished finish. So this piece has been polished to about a 3000 grit. So you can see the aggregate, and if we get it at just the right angle, it would probably show very shiny, but it's hard to catch that on camera. So the advantage of this, all the same mix, we can put different finishes on different parts of the panel. So you can accomplish a very interesting different set of finishes on your panel, and they'll all be kind of in the same family of colors. With our local materials, this is what you would call an exposed aggregate. And so this one, you see, you really see the basalt aggregate, and you see the gray matrix kind of in the background. So that's a very rough, raw kind of look. And there are actually a lot of buildings in Waikiki and downtown that have this finish. If you do a deep acid etch finish like this one, then you start to see the basalt aggregate and the sand, but it's a very attractive finish. And the nice thing about this with gray concrete with some black pigment is that no matter how deep you go, the finish looks very uniform. So this is one of our favorite finishes, having the black aggregate is having the black matrix as well. And then this panel right here is a light acid etch. So this one shows just a little bit of the sand and a nice texture, but it's very, very fine finish. And these are all local materials.
And that being said, there is an increased awareness and appreciation for Go Local. So I want to commend you for that. Even the client that you have, that is basically a national, international client here, that you did great, and we're trying to consult them in going more local, but due to their philosophy, they weren't willing, but you tried, and I really want to commend you for that. Zuri is going to circulate a couple of pictures that I allowed myself to take from my Ohana practice that we've done several projects actually in precast, one of our favorite materials. And you see here, this is prefab, and it goes through different typologies. So some are basically dwellings. This one here is interesting to look at because it's a sandwich panel. So it actually has rigid foam insulation inside. Again, once again, also attractive for here because people might actually say, well, black is great, but if you wear something black outside, we get hotter because it absorbs more the heat. Once you put rigid foam insulation behind, you keep that heat outside because your structural concrete is actually on the inside. And you see other typologies. You see a kindergarten out of prefab concrete. You see a community grocery store out of prefab concrete. You see single-family housing, multi-family housing. And this is the H home, by the way, that you consulted on, where he also taught me that when we had to price it and be competitive with a standard current, that you said, well, I make a form for a beam, and we try to reduce the elements, the members, to the most minimal. And you said, well, if I can reuse the nature of your principle, is I reuse that form over and over again, so the more I produce, the more the price goes down. Whereas down there on the job site with cast in place, they got to do every form individually and again. So actually the efficiency is one thing, but it becomes really effective long term. And it also sort of is then attractive to standardized sort of systems, right?
Yeah, you make a good point that repetition in precast is a very cost-effective method of doing it very economically. And even when you get into more fancy forms, if you do those repetitively, a lot of times owners and architects are surprised by what they can get for their dollar if they're doing things repetitively.
And that was an excellent slide that Yuri just brought up, because this became the most important drawing that people, when they looked at the renderings, which I saw before, they said, well, this looks pretty good, but too good, it must be expensive. And we basically said, this is a kit of parts, you can put it together in a couple days. and then basically you're done with the job. And with the high cost of labor and unions here on the island, that's really a big argument.
Right. And as we talked about repetition, we also talked about the fact that once you have that form made, you could put a liner in to give some Hawaiiana feel to it, and actually we did bring a form liner along with us today. So if you look at this, and I'll tilt that, you can kind of see the wood grain in this. And this is urethane rubber, so it's very flexible, and we actually make these in our plant. We'll take a piece of stone or some wood, and we'll put it down, and then we'll pour urethane rubber on it, and then you put this in your form, and then you pour concrete over this, and you can use it up to 30 to 50 times, and it really doesn't really wear out. So it's a very economical way to give some more articulation besides the finishes we talked about. You can put the form liner in to give you patterns, or wood grain or anything you really want, since it's so moldable.
No, that's a very innovative way. So there's actually multiple layers of innovation. There's also hybridization, I would say. I mean, the necessity to put in metal, rebars is already one. And so I see another piece here, which basically the delta beam that you wanted to share as well, which is a hybrid system.
This is a new, well, it's not real new. It's been used in Sweden for maybe 10 to 12 years, I believe. But you can see the cross section of this if I put it this way. So this is a steel element that we buy, and this sits in the building on a column on each end, like this, and then hollow core pieces will sit on each side of this and span across. And then this all gets filled with concrete with the topping, and this gets filled. So you might ask, well, isn't this a fire issue with that steel plate there? Well, that's really just temporary for supporting the hollow core, and once it's all poured together, then you don't need that bottom plate, and it could melt in a fire, and it's still all structurally okay. So so this,
it almost becomes a rebar in the whole.
And there actually is rebar inside of here. So the advantage of this is that if you have a real tight floor to floor, and you don't want to have a beam dropping below your planks, then this is flush with your planks. So that's the real advantage of this system. But that's a new innovation that we've just done our first building over at Plaza Waikiki is the name of the project, near the convention center, using the delta beam.
So the show, as our show in general, is really trying to encourage everyone been involved in the building, in the act of making buildings, thinking buildings and making buildings, that there's a whole new dimension to concrete on all these levels we've talked about, that we want to encourage architects, emerging architects, or students who are already doing it, but also clients and developers to think more outside of the box of concrete. The massive use of concrete, not always in the most sophisticated way. I think in the 1970s, especially, Waikiki is an example for that, has not necessarily helped the public appreciation. A great building on the other side, I believe, is Osipov's IBM building, where he uses beautiful prefabricated concrete louvers on the outside that shade the building bioclimatically. So this is a very nice building where you can say, concrete is liquid stone. It almost looks like it flows, right? So it's that's
and those are symbols of the punch cards back in the days of punch cards with computers. So IBM was it's a very neat building, and it's all precast exterior there. And
but it's also so minimal and so abstract that actually everyone can read. Some people actually, you have your shirt, your lower shirt, some people see that it's like reminiscent of floral forms in there. So it's like you can see in it whatever you want to see. So it's not literal, it's abstract, which is actually what these times were about. So we're getting to the end of the show. I want to close it off with two even more unconventional samples here. This is something when we got to know each other, the first thing you asked me was actually, do you know autoclaved aerated concrete? And I said, yes, very much. We don't want to go too much into detail. We could make an extra show because I have a building that I've made out of it for the German Bundeswehr, for the Army. But it's basically this here, and it deals with, it would be great for the tropics, that's why you asked me, because it basically says, I aerate, so I put a lot of air bubbles, pockets in there. It's made by aluminum powder that's basically in the mix, and then they heat it up and it extrudes and burns away, and it leaves all these little cavities in there. So it's a very predominant building material actually in Europe. It's sort of what the 2x4 wood frames are here, is almost that's what it is. And the advantage of this is that it's basically also a structural skin, not in a textile way, not in a breathable way, but it's an insulating structural element. So it basically keeps the heat out by at the same time basically being the structure of the building, at the same time already being the finish. You just have to plaster it over, so it's very durable. But then again, we like it, we dream about it, but it needs facilitation, it needs logistics, it needs either a manufacturing plant that we don't have here, or it needs to be shipped in, which again raises the question about how locally appropriate is it. And then the other one, which is even more out, again, brings me back to Arizona, my years. This is a former student of mine, Pavel, who made this here using a new crazy machine, I would call it. This is a 3D printer. So there's some wizards who basically engineer concrete in a way that is so smooth that you can basically use a machine that's basically extruding these tubes of concrete. And then, I mean, this is obviously up for creative minds, the new generation, to think about, could we make real buildings out of that? But it just points out that obviously that Frank Lloyd Wright definition of liquid stone can't be more current than in these days. So with that, Les, thank you very much for this really great introduction to your very innovative world.
Well, thanks for having me.
And we hope to have you back at one point. I'm sure we will. So
Okay.
thank you very much. And visit us next week again. We're going to have sort of a complementing material. We're going to have breezeway. We call it easy breezeway most likely. So it's a fenestration system that could be put into your buildings that you just keep the framework, and then to allow to get the most natural air conditioning through, you could use that system. That's also a system that has tradition on the island and also gets innovated. So that's going to be our next show, the Thanksgiving show. So if you don't have anything else to do besides eating turkey, then tune in. And again, thank you very much, Lance.
All right, thank you.
Bye-bye.